Hi guys, welcome to Learning Electronics Repair, and we're here to announce that today we are closing the signal injector design competition. This is the design a signal injector that fits into a pen, and we have quite a few entries actually, so thank you very much to all of those out there who took some time to put your entry in, and we'd like to build all of these versions. Okay, so first of all, we'll just talk a little bit about PCBWay.com, who are sponsoring this video, and how we can upload the project. So with PCBWay.com, one of the great things we have is the shared project section. This means, with your permissions, by the way guys, or you can do it yourselves, you can upload the project, or we can, to here, and then if anybody wants to order, they just click, and they can also search. So for example, we can put signal injector into the search, hit search, and we see one already. Oh, that's Tim's.
Oh, it's Tim's one, yeah.
Yeah, this is one of the entries for the competition anyway. So I'm happy to upload these files if you want to send them to me, or you can upload yourself, and then we'll have them all here. So anybody who wants to build one of these projects, quite simple, click on it. There's the information, look, it's all there, and you can add to the cart. If you add to the cart, then you order the PCBs. And by the way, whoever uploaded the project gets a 10% commission. So maybe you guys prefer to put them on yourselves, yeah?
This is something for me. Look at this. If you're too lazy to build this yourself, you go simply for PCB and plus assembly.
Oh yeah, this one.
Yeah.
And you can have them already built. Yeah, so again, you can use the assembly service. Normally the minimum order is 5, so when you order you get 5. Okay, so that's how the projects will appear on PCBWay.com, but let's have a look at your designs. Okay, so the first one we have is from Alex. These are not in any particular order, by the way, possibly in the order that they were submitted to me, but no other reason. So Alex has given us a Gerber file. That means we can upload that into PCBWay.com and actually have a look at this one. And here we can see the PCB. So probe, capacitor. This is a through-hole version. I think Alex is probably the only one who actually submitted a through-hole. So Alex, I'm sure you'll be watching this. I will email you anyway. If it's okay with you, we'll add this as a project. I'll get some of these ordered, and we can put this together and see how well this one works.
I like how he did the thing with the 45 degrees of the components.
Here?
Yeah. I really like the idea there, yeah.
Yeah, and I think this actually is double-sided, this board.
Yeah, it is, yeah.
A little NPN transistor here, and then there's some more that fit on the other side. Yeah, you can see the holes here, which are for the other components. Yeah, I really like that, because obviously that gives you like a narrow PCB.
Indeed, yeah. And once you saw it, this is so obvious to do that. Yeah.
Yeah, and yet in a way you wouldn't think of it.
Yeah.
So nice one, Alex. Oh, he's even put a little L logo on. I mean, what can I say? Yeah. So, okay, so we'll get those ordered. We have the Gerber. That one's easy enough to do.
And he's probably using one of these little battery thingamajigs on the... oh, no, this is a probe. Where's the battery?
The battery fits here.
Ah, okay.
I think, actually, if we look at Alex's email, we can see how that works. Okay, and this is actually the same schematic that I used. Alex says he doesn't do a lot of electronics. He's learning, so he didn't design the circuit to use mine. That's absolutely fine. But what he's done a very good job of here is actually the PCB. So here we can see it's a little bit more, and it's glory now, double-sided. And this is a homemade clip he used that actually
brilliant.
Holds the battery.
I love it, Alex. Yeah, I love it. Yeah,
absolutely love that. Overall size. Here we go. Oh, these are the dimensions of a Sharpie pen.
Ah, okay. Okay.
That's what it is. Okay, so Alex, I will email you, but let us know, and we'll get some of those ordered, and let's build it and see how well it works.
That's a cool design, mate.
Nice. Thanks. Well done, Alex. And this is Jeff's version. So again, Jeff has submitted a Gerber, so we can upload this to PCBWay and have a look. And he sent some pics as well. So the pics, let's see what we have. Is this the schematic? Oh, okay. So again, I think this is a transistor version, is it? It looks like a multivibrator. This is the battery. He gives us the battery size, a retainer. Okay. This is surface mount. Let's look at
I'm curious for the pictures.
I am very curious. Let's have a look at the pictures. And here we are. So we have a Sharpie. Yeah. the injector there. Let's have a look. Oh, there's the assembled one, so it does fit into a Sharpie, which is what I specified. Although we will get some PCBWay pens, and we'll try and put them in those.
Yeah, let's try it out. Let's hope they're not too small.
No. Oh, and there's the Sharpie. Okay, let's upload this Gerber and have a look at how the PCB looks.
Yeah.
Okay, then this will be where the battery fits, or the battery holder. And yes, that's the output capacitor, Luke, and then this is where you solder the probe. Yeah, nice one. So again, we'll order some of these from PCBWay.com. We'll get them built, and we'll put this one through its paces. Okay, and next we have Rod's version. Rod sent this all the way from Tasmania.
Tasmania. I thought there were only the dust devils there.
I thought the schematic would be upside down, so we turned it the right way up for the Northern Hemisphere. Okay, sorry about that, mate. Couldn't resist. So yeah, so this has a resistor, 2 capacitors, and a chip, and a start button. So this is interesting because I thought at first this was going to be something like the Schmidt trigger inverter type.
The idea I had, yeah.
That
but
you had.
This is some more on the left line, but I love the idea here.
Yeah, and this is far more elegant. So what Rod has done is used one of these LTC 1799. Yeah, a resistor sets. That sets a frequency get. SO23 oscillator. So this is like a surface mount transistor size, but 5 pin. Same size as those tiny logic, Schmidt triggers. Yeah, so you have a resistor there, that sets a frequency, a capacitor, and out comes your square wave.
Brilliant.
Absolutely excellent thinking, yeah. I've never seen this chip before, did
I hadn't had any use for that, but you know, now that I know that it exists, I probably can come up with some ideas for that. And I love this. Yeah, I really love this.
Love this. Yeah.
And
Luke, 1 kilohertz to 30 megahertz.
And you have a look at this. This is 24 years ago that this chip was designed. So
wow.
This is a long some time now. Yeah.
Okay, so we really like that design. I'll just show you the layout. I don't have the Gerbers for this one. I will contact you, mate, but at the moment I can't upload this one. I don't actually have the Gerber. But let's have a look at your design. Okay, so battery 3 times AG1. So I'm guessing there's 3 batteries.
Yeah, so you come up with 4.5 volts. Yeah.
Yeah, we'll have a look at an AG1 battery in a moment. I guess these are little disc batteries. Yeah, here's a PCB, so you can see that's the little device, SOT23. Shouldn't be too difficult to solder this.
No.
Resistor there, 2 capacitors and switch on the back of it. Oh yes, there must be little like coin type batteries because this is the clip, the holder.
Yeah, brilliant.
Okay, nice one.
Yeah, absolutely brilliant.
Yeah, we can see the layout there. Yep, we
and Rob,
really
I think
like
you're taking away the smallest PCB here. Yeah.
Maybe. I think mine was slightly smaller, but mine didn't include the battery or switch.
Okay.
So yeah, I think you probably are taking in the smallest one here, including the batteries. Yeah, 19 millimeters and 1.9 centimeter. The PCB is only 11 millimeters, 8 millimeters wide. That should fit very, very nicely. It's usually nickel strip folded and then soldered to make the terminals. Yeah, nice. Okay, so I'll get in touch with you, mate. Let's get the Gerbers and let's get some of those ordered and get those built. I think this one's really nice.
Clever.
Yeah.
Very good.
Okay, so this is Tim's projects. Tim has a YouTube channel. I'll put the link because he made at least 1 video, so I'll put the video link in the description to this video. Tim actually submitted 2 designs. There was never any stipulation, you can only submit 1, so fine. This version uses a 7555, so this is a little 6-pin surface mount. It's basically a 555 timer.
This is the CMOS version of the 555 that uses way less current, 7555.
Yeah, this actually, I'm just thinking now, this actually uses more components, support components, than the other one that we built. But
that's the downside of using these 555 things, because you need a bunch of components on there.
Yeah. Do we need that LED?
Looks good.
Otherwise, I mean, if that is just an indicator, then 1, 2, 3 capacitors and 3. It actually uses the same number of components.
Yeah, and he says omit LED if increased runtime is required.
Yeah, exactly. So then we actually are pretty much very similar to the version with the multi-vibrator with the 2 transistors.
Yeah, you pretty much same. Yeah, I would say same. Yeah, maybe yeah, got one more cap on this one.
Yes.
But there's no less resistors. No, you use 4 resistors too.
And in fact, that capacitor is just there for basically like decoupling. May not even need it.
Probably not, because you're coming out of the battery. So battery, this is the cleanest energy voltage source you can get. Yeah,
pretty much. Yeah, yeah. So nice little design there. And here are some images, so we can see. This is an interesting battery, by the way. We're going to talk about this a little bit separately, but Tim is using these CR425 batteries. You can see there the 755 on there. So it's actually an 8-pin SOIC, small outline IC. It's not a 6-pin. I think it just uses 6 pins. It'd be interesting if they made those, you know, in like an SOT23-6 package.
No, you need, if you want to have compatibility. How do you say this?
If you wanted to work the same as.
Yeah. If you want to do pin compatibility, then you need to have 8 pins. Maybe there's a little smaller packages available, something like the little pads under there and stuff.
Interesting.
But 545 is an old design. It's a real old design.
Yeah.
So, well, you can do this, and the CMOS version actually uses less current. And Tim, I love your designs. Always, I love your designs.
Yeah.
This is so clean, so nice.
Yeah. I mean,
mine always look messy.
Yeah, exactly. I mean, as we showed originally, Tim has already uploaded one of these projects anyway. I didn't look into which, but he already has one of these on PCBWay.com. The other version that Tim came up with, the multi-vibrator, the classic multi-vibrator, of course. Yeah. So, I mean, the component counts about the same. Again, he's got an LED in there, which you don't need as part of the actual circuit. A little battery holder. Okay, so one of these 2 versions is already up on PCBWay.com. I'll have a chat with you, Tim. Maybe we'll upload the other one as well. But it's your call, it's your project. And again, there is an image of the PCB. So I would say these are about the same size.
Pretty much, I think.
Yeah. Tim, in the comments down there, yeah, but look like the same size to me. Yeah. Okay, so yeah, nice one. And this is Thunder Ace's version. So once again, the multi-vibrator. And to be quite honest, this is such a classic circuit death. I mean, why? You could say do other, but I do like some of the other ideas people have come up with. So yeah, there's the schematic. Again, a little surface mount with an AG4 cell.
These are tiny, right?
Those batteries, they're going to have to be small.
Yeah.
I mean, these are, if anything, 1206. Yeah. So effectively like 2 of those together. That's small.
Yeah, and probably Thunder Ace has the other transistor on the back side.
I would say he probably does. Yeah. So
this will be double-sided.
We can go bottom. Yeah. On the other side. Yeah. Okay, so that's nicely designed as well. Once again, let's get this uploaded to PCBWay. Now, I noticed that you did actually give us some files which could be Gerber files, but it's not a Gerber zip file. So if you could do me a favour, email me the zip file. I'll get that one uploaded as well. So next time we'll have all the PCBs all built in.
Cool. Okay,
so that's everybody's submissions. There's just mine and yours to talk about that.
Okay.
And why not? I'll go first.
Go first, please.
Okay, and we looked at this one last time, so very quickly, this was my version with the double transistor. So we have 2 designs using this method. There was a number of transistors you could use here, but that's one I chose. It's a very easily available one, very cheap. So this is an SOT23, the same size as a normal surface mount transistor. It just has 2 of them in the package. Yeah, and we can have a quick look at the PCB. Just ignoring these pins because I just effectively wanted a placeholder so I could put a hole in the PCB.
But this gives you a good idea how small this is.
Oh, absolutely. This thing is tiny, guys.
Yeah. These are normal DuPont pins. Yeah,
exactly. If we just actually go to the PCB. So this one is actually 40 millimeters long and the width is just 5.8 millimeters. Yeah. That's getting towards the smallest size that PCBWay can actually make.
Yeah. If you're doing this little tiny stuff, there are limits for what they can measure, what they actually can build in the factory.
In fact, on the previous video, a link from this one, the dimensions are on there. Minimum track size, minimum spacing, and minimum PCB size.
But you could have gone smaller.
I could have gone smaller. This is single-sided. It could be double-sided.
Exactly.
I did that because I'm actually using 0402 components, which are quite small anyway, for ease of construction, if we can call it that. But we'll see when I have to build it. I did it this way, and I didn't actually put the battery or the switch on the board. I'm literally going to wire them onto here. So from VCC pin and ground pin, this is the output, this one here, to the probe. So I'm just going to run wires across to a switch and then mount the battery behind the switch.
Oh, you're cheating. You don't have the switch on board.
No, I wouldn't say that's actually cheating. I would actually just say I never specified in the competition the battery has to be on the board. It just has to have one. Yeah. But I think quite a few people here have actually been thinking out of the box a little bit. So.
Yeah, and this is the idea of this, to think outside the box. This is the great thing about these. Do something, build something.
Yeah.
And great that all the people are with us here.
Yeah. And I'm actually going to use the same battery that Tim is using. Okay, so that's that. And then last we come up with Jet's idea.
This was my version here. So because when Rich came around with that, of course, my mind started. And of course, then something strange happens. Of course, as always, as it does.
That's why it's so much fun.
Yeah. So I didn't use a oscillator, or I didn't use transistors. I have 2 NAND gates in here.
Inverting Schmidt triggers, I believe.
I have 2 inverting Schmidt triggers in a little chip over here. So this is my little chip here. So one of them forms a oscillator with R1 and C1. The values on this are completely arbitrary. I have no idea what would make good values. We have to have this thing around to test this out.
So they set the frequency?
Yeah, they do. Yeah.
Okay.
Yeah. This one over here, these 2 are in parallel because I have no clue what a good value of the capacitors would be.
So probably only need one of those actually on the PCB.
Yeah.
Okay.
Yeah, so this is a little inverter. So because every inverter with an RC combination at the end is an oscillator.
Okay.
Yeah, I'm coming out of one here, and then I'm going back into the second one, and this goes to the output. So this is a buffering stage here.
Okay.
And this was mainly done because this is easier to get. The chip with 2 on is in there. It's easier to get. Still a 6.
And this is about the same size as those little double transistors.
Yeah, it's the same size. Yeah.
Okay.
I probably get away with less components, even especially if I dismiss C2.
Okay.
Yeah, so component count will be a bit lower.
I'd say this is the lowest component count of all the versions.
Could be, yeah.
So far until the power supply.
Yeah. So after that, I thought, okay, how do I power the thing? And all you guys always have batteries in there. And I thought, okay, let's use photodiodes. So photodiodes, if you remember your little calculators back in the days, that has a little, looked like a solar panel on there. These were photodiodes. So every one of them should generate 0.5 volts, maybe. So I'm putting out 2.5 volts over here, and I hope this is enough to power the little chip, because this isn't tested. This is completely theoretical.
Yeah. Actually, I've seen quite a few old calculators at the car boot sale.
Oh, we could get one of those.
We can get one of those and just
rebuildability wouldn't be there, but we can try with that. Yeah. And the big upside here, I don't need a switch because
it's always on.
Yeah. This is a light activated frequency generator.
Oh yes, not much good for fault finding in the dark.
Yeah, you don't want to do this in the dark, and I can't say how much light it will need. So.
And I can't see why you'd want to be injecting signals in the dark anyway. So
I only have a ground coming out of that, and I have a signal over here with a little pin thing, and the PCB gets pretty tiny. So I'm running around with 7.7 by 34, but I don't have a switch, and I have my battery, so my power source already on there. Yeah, and if you look at the 3D view, you can tell that most of the size is needed for the photodiodes. So on the back, there's just this little stuff sitting and doing its thing. Again, this is completely experimental. I have no idea if this would work.
But I have to say that that's elegant.
I like the oscillator more, and I probably can get away with even less components than. But you need the resistor. You need okay, come on.
Okay, so that's the designs we have. We're going to get all these built, and then we'll put them together and see how well they work or otherwise. Just want to chat about a couple other things on this video. Those of you who watched the previous video with the competition, you'll know we talked about this or something similar. It was talked more in depth in the comments, but these are cheap, you call them AirPods or something? Yeah.
I don't know what these kids these days call it.
No, but they're like little earphones, and these are Bluetooth. Yeah. And in here is a little Bluetooth receiver, so you can connect your mobile phone or whatever Bluetooth device to this. And we did talk about dismantling one of these, which will have a battery in.
It has a battery in there, yeah?
Yeah.
I have no idea how that gets in there, yeah?
No, it has a battery in, and it has a little... Oh,
yeah. Oh, look at this. It's even blue.
so this is the one we want. This is the blue one, and then
so,
this is
yeah,
probably the slave one, okay? Yeah. So we thought if we could dismantle one of these, then we have what we need.
Because it puts out some kind of signal that you put in there with your phone.
Well, obviously what comes out of it is audio.
Yeah.
Into your ear. So we're going to have to take one of these apart. Now, this may be a bit destructive, guys, but...
A bit?
Yeah, slightly destructive. Well, Carlos is not here, so we might be okay. Yeah, these things were very cheap, weren't they?
Well, for science, you know.
So the question is, can we get this thing open?
You know that I can't see any blood, right?
Oh,
okay, this was easy.
This is going to come up easily.
Okay.
Ah.
There's your little signal generator, you know.
Do you know, I think this is too wide to fit in the pen.
Ah, come on, use a bigger pen.
Use a bigger pen. Yeah, this is too wide to fit in the pen. But this is probably not the smallest one of these things you can actually get. So let's see, can we see what battery this takes?
A really tiny one.
A really tiny, rechargeable. So, how does this recharge?
See the little copper pins there?
There?
Yeah, this is where you put the voltage in and just recharges in the
Oh!
box here. Oh no, everything's gone crazy here.
So you could make this rechargeable. Okay, so we've not done this, guys. But if anybody would like to try to develop this, then I think we can allow a late submission. Yeah, because this is all for fun. Yeah, all for fun. So can we see what's in this? I mean, you could make a smaller PCB than this.
Well, it's a highly integrated everything in one chip thing.
Okay.
You we'll have everything in there, and little whatever this is.
Well, let's have a look.
20 pin, something.
So that is the marking on the chip. You can read it yourself, guys, so anybody interested, you'll have to go and see if you can look that up or ask the AI what that is. If you can't get one, well, you can always get some of these and just desolder it.
True, yeah.
Yeah.
And then these are the cheap ones. This is probably $5 or something.
Yeah.
So you get a complete set there.
Yeah, on the back, there are just some capacitors. 1, 2, 3 capacitors, nothing else.
This is probably antenna, yeah.
These are LEDs, the LEDs.
Yeah, these are the two LEDs.
Which you don't really even need, but you can have. So it wouldn't be too difficult to reverse engineer this thing, to be quite honest.
Oh, simply use a bigger pen.
Or find the data sheet. If you find the data sheet for... Yeah, use a bigger pen. We'll leave it at that. But if you find the data sheet, you can probably figure that out. So anybody who's really interested, who'd like to build a Bluetooth one, that's probably a good place to start. The advantage of the Bluetooth one is you can inject anything. So not just a sine wave or a squarish wave. You can put music in.
Sure. Yeah.
Audio sweep from like an MP3 player or something. Yeah. So you can inject what you want. So guys, if anybody wants to play with it, that's that.
That's maybe an idea, yeah.
Yeah. Okay, and one more thing we'll look at on this video. And that is these. So this is something that Tim came up with. I've never seen these. Maybe Tim is a fisherman, because these are fishing float night lights. Yeah. The night lights for fishing floats.
And I have to admit, I've never seen these in my life.
No, but we liked them. So here we have the battery. I'll just show you the size of this actually. So the thing is about 4 centimeters long. That's the entire unit. So this contains an LED as well. This is the battery. So yeah,
brilliant.
Brilliant.
Absolutely brilliant.
But it's very narrow.
Yeah.
A little plastic thing on this. That's like a little cover. So if we put this back into here.
That one. I think you need to do the thing the other way around.
What?
Do the pin into the thing.
So you take it out. You put the pin into there. Oh. Okay, guys, slide down. So if you put them in that way round,
the right way around.
Yeah, they light up. So there we go. There we go. And that's, I think, is 2.5 milliamps hour. This probably draws about 1 milliamp or something. So it's probably like a couple of hours or so.
Yep. And if you have a fish, hold it to the screen right now and see if it's attracted to the light.
Yeah, but the great thing with these is they come with a charger. Yeah, so USB charger, plug it in. Now, Detlef said he would be very interested to see what's inside this charger.
Because I want to see the mechanics for that. Yeah. I love the idea here, but I want to see. And I saw how Tim did that with little wires, things. And you know me, too left-handed, so I would die with that. So I'm very interested how they're doing this on an industrial scale. I
then pointed out we only have one charger.
Well, Carlos isn't here, so chances are the thing will live.
Yeah. So, can we open this up? Guys.
Okay.
Okay, guys, a little bit of delicate adjustment. And we have it. So that's the actual PCB. And what Det was interested in seeing is how it actually connects to the battery. And I think it's fairly obvious now. So we have two little clips like so. And when we put the thing in, it connects,
That's clever. And they're using the outer shell to give it stability.
Yeah, and they're using the edge of the PCB to stop you plugging it in.
Yeah, too far.
Yeah, so you can't plug it any further than that.
You need the housing to have the thing stable.
Yeah.
Other way around.
Yeah, so basically when these go into here, that makes the contact.
Can't go further than that,
No, you can't go further than that because of the plastic in here as well. So that's how those work.
Clever.
But I was thinking if you were using these to make your own project, and this will have to be glued or taped back together again, okay? We can see that this lights up. So if we take one of these apart, we should have here, where the LED fits, contacts.
Yeah, there must be.
And then we can just wire a switch from that to our project.
Or, you won't have this frequency generator running all day, so... it's gone already.
It's gone already?
Yeah, there's the LED.
There's the LED. So let's see if we can open this up.
Yeah, you won't have the function generator running all day, so you probably get away with soldering the thing on because it's what lasts for ages.
Yeah, probably.
Yeah.
Okay, guys, so that didn't work too well. I managed to break this. You can see where the actual pin goes down inside that.
And the LED still alive.
LED actually still works.
What a trooper.
Yeah, it's absolutely. But unfortunately, this is like all potted in with glue. So I thought you could easily take these things apart maybe and connect some wires from that, but I'm not sure how easily. Maybe if you're a little bit more delicate than I was in taking this apart, you might be able to do something. Yeah, it looks like I think I can actually see the legs of the LED.
Yeah, true.
Yeah, so it may be possible to do that, guys, but certainly these batteries are ideal for electronics projects. Anything that doesn't draw much power. I mean, these are so small. They really are ideal. Okay, guys, so hope you enjoyed that. Nice little chat today. I'd like to thank Det for joining in.
Thanks for having me, mate. Yeah.
Always interested to hear your opinion on these things.
Always fun, and this was a creative...
It certainly was.
Brilliant,
And we broke some things.
Yeah. Thanks to all the people who joined in here.
Yeah, thank you very much. Obviously, you've put your time and effort into that just for fame and not even fortune, really. I'd like to thank PCBWay.com for sponsoring this video, allowing us to make these sort of videos. Okay, so hope you enjoyed that, and we look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.